Hey class, how you doing today? This is an overview of our lab number 2. So if you're doing the virtual lab, this is the first of 3 videos. So the first video here, I'm going to give you a quick introduction to the lab and some of the concepts you need to understand in order to complete the lab. In video number 2, we'll do part 1 of the lab, and in video number 3, we'll look at part 2 of the lab. So in this lab, we're going to test out 3 different metals. We're going to compare magnesium metal to calcium metal to aluminum metal. And so right now, you should be able to rank these in order of reactivity based on all the trends and things that we learned about, like ionization energy and effect of nuclear charge, electronegativity, size, the distance, the electron is from the nucleus, the valence electron is from the nucleus. All those things are factors that are going to affect how well an element such as this metal or these metals reacts. And so in part 1 of the lab, we're going to try to react these 3 metals with water. And so sometimes it's hard to see what's going on here. And so it just so happens when a lot of metals react with water, they will turn the water basic. Alright, so we're going to use a chemical indicator. It's a molecule called phenolphthalein. And phenolphthalein, when it's in an acid environment or when it's in a neutral environment, even a slightly basic environment, whenever the pH is about 8 or less, it's going to be clear. You won't be able to see it. So right here we have a flask. There's a chemical in here that has a pH of less than 8, and phenolphthalein has a clear color. You can't see it. However, once that pH goes above 8 and it turns basic, it's going to turn pink. And so as the pH goes up, it'll get a deeper and deeper pink color. So because metals, here's an example of magnesium. Magnesium, if it reacts with water, what would happen is it would react, and the magnesium would link up with an oxygen and a hydrogen from 2 different water molecules, and that would make a chemical called magnesium hydroxide. And so if you remember last year from biology, chemicals that contain OH, that's called hydroxide, that will make a chemical, a liquid such as water, turn basic. So this is a base. So by producing a base, it's going to make the pH go above 7, and that will turn it basic, and then we'll see a pink color. So in this step, in this first part of the lab, if you see a pink color, that is from it reacting. Right? That's a sign that a reaction is taking place. And we're also going to produce some hydrogen gas, and so you're looking for bubbling. So bubbling and a color change, a pink change from that phenolphthalein indicator solution. In the first step of the lab, I should say, out of those 3 metals, one metal is definitely going to be the most reactive. So try to predict which metal is going to be the most reactive. The other 2, they're not as reactive or don't react. So we need a way to differentiate them. So we're going to do a second test. Alright, so you're looking more bubbles, the deeper the pink color is, the more the metal is reacting. Take the other 2 metals, and the directions will tell you which 2. And we're going to test them by heating them up, and we're going to try to get them to react with oxygen in the air. So if we heat up chemicals, typically we give them energy, they're more likely to react. And so we're looking for, does this metal, does it react with oxygen, yes or no? And so look for the signs that a chemical reaction is taking place to help you figure out whether or not it's reacting. And it's pretty easy to see when you do this which one reacts and which one doesn't. Alright, so here Bunsen burner. Bunsen burners get super, super hot, like 1,000 degrees Fahrenheit. So that is the lab. Alright, so by midnight on Monday, you need to have the lab turned in. We get the test on Tuesday, so you need to have the lab submitted by the end of the day on Monday. So that way your teacher, Mr. Rafferty, or myself, Mr. Lehman, can take a look at it and assign a grade. Alright, so it needs to be done Monday, your asynchronous day. You're also going to have class time Thursday and Friday, so that's a lot of time. So there's no reason not to get it done in this allotted time.